Sigal Mijovic, the head of protein development at Equinom, and I'm very excited to be here today and to discuss how we bring this vision Rick spoke about to life, and how we help manufacturers design and produce the products they envision together with our AI system. Equinom developed this AI tool to provide a faster and more accurate way to breed in multiple complex traits to match ingredients to clients' requests. The AI enables us to determine the influence of multiple biochemical and physical traits of a seed ingredient on the final product functionality, such as taste, texture, and even the nutritional value. The AI has machine learning capabilities that can screen Equinom's massive seed bank in order to find matches between a source seed traits and the functionality we need in the end product. And here is how it works for manufacturers' product process development. Let's say a client comes and he is looking for an ingredient that will produce a juicier burger. Then the AI translates this requirements into Equinom's product definition, which includes biochemical and physical seed characteristics. Then the algorithm uses this definition to search Equinom's seed bank in order to find matches. And if matches exists, and often, of course, there is more than one match, we do an internal validation to confirm that indeed this variety has these qualities and produces the functionality the client requests. Then we send samples to the client for their validation. And after the client confirms that the variety indeed matches their expectations, we move on to large-scale ingredient cultivation. Of course, the AI is just one tool in our overall breeding strategy. And now I would like to discuss how we use it in protein ingredient breeding. So as was mentioned, of course, in the last slide, it all starts with our clients. So either the food companies or the ingredient companies, the client approaches us with their requirements, and the AI and our internal food application lab translate client requirements into an ingredient definition. Then comes our biochemistry lab with its high throughput capabilities that evaluates thousands of varieties for different traits such as protein content, protein composition, starch composition, and many more traits that are important for the product, and selects the varieties that match the requirements. In the rare event that a perfect match is not found, the bioinformatics team enters into the picture and defines the natural crossbreeding steps to produce the exact variety the client requires. Finally, we use these crossbreeding steps to grow the ingredient. And now I would like to make it more tangible by looking at two case studies on how we did this breeding for specific characteristics. The first case study comes from our tofu breeding program, in which we breed soybeans for high quality tofu. And when it comes to tofu, we try to find the fine balance between cost effectiveness and product quality. When it comes to cost effectiveness, we measure the tofu yield. And when it comes to the tofu qualities, we're referring to its sensorial attributes such as taste, texture, the water retention of the product, protein recovery, and the nutritional value. One of the main characteristics that influences tofu quality is its texture. And in order to measure the texture of the tofu, we use the penetration method, in which we measure the time it took for a 20-gram metal ball to penetrate the tofu surface. And then we classified our different varieties based on their penetration time into 4 different hardness clusters of low, medium, hard, and extra hard. In this video, we will see 4 tofu varieties taken from 4 different hardness clusters that have the exact same protein content. The only difference between them is their protein composition. Let's have a look. Think about this. The only difference between these varieties is their protein composition. There were no differences in processing, additives, or other factors. Imagine the potential of using such a system in your products. So after we did tests on over 100 different tofu varieties, evaluating numerous variables, the AI gave us a very clear picture of the protein components that had the biggest influence on product texture. So, for example, if a customer comes and he would like to breed for a hard texture tofu, here in hardness cluster 4, then we need a certain ratio between different protein components in order to breed for such a line. Of course, texture is not the only trait that influences tofu quality. Therefore, we measured other qualities such as water holding capacity, protein recovery, taste, and defined a code for high quality tofu. What we have talked about so far is tofu quality, and now we are applying the knowledge gained from the tofu case study on the relationship between protein composition and functional properties such as emulsification, foaming, water holding, and gelation in order to design our next-gen soybean variety and to upgrade meat alternatives such as making juicier burgers. In fact, we are creating the first AI bred legume designed specifically for meat alternatives.